Let's now look at the softmax activation function. What we have here is the value on the left hand side. We have the input values x that go from -10 to +10, and these are the inputs to the neuron A that is using the softmax activation function, and it calculates the values as shown in the green box on the top right. The calculated values are in column A, and all these values should add up to 1, as we'll see in just a minute. And on the right hand side we see the curve or the shape of the softmax, which is shown by the blue colored line, and the magenta dots are the data points that are in the column A on the left hand side. Let's now go to Colab and use the softmax activation function. And this usually is the last layer in a neural network where the final values are calculated. So the first we'll say softmax and calculate the values of x. But before we calculate the values for the curve, we'll put the values that we have seen on the slides, and these are going to be -10, then we have -5, then after -5 I think there is a decimal value of -1, so let's add that value, -0.1, 0, then we have 0.1 plus 0.1 plus 5, then we have plus 10. So with these values we can calculate the activations. So tf.keras.activations.softmax. Now if we use it as is, it's going to throw an error. As you'll see, if we try to print the value of y, we get an error which is the cannot use the 1D shape. And so for that we need to reshape the value of x. We say x is equal to tf.reshape, and this is going to be the shape is going to be x. For x we are going to reshape x 1 comma 1 comma this is length of x, and so now we would get the activations, and the idea is to see if the sum of activations is 0. So we are going to print this tf dot reduce sum of x. We need the dot math there. So tf dot math dot reduce sum of y, sorry, it should be y, because those are the activations. And when we look at the output, we see that these values, which are the calculated activations, they add up to a value of 1. And now we can go ahead and create the plot that we are trying to get at. So for that we'll use a different set of x values. We'll say tf dot linspace. We'll go from -10 -10 to +10, and we use 100 values there. And now for plotting we need to remove any extra dimensions. So we'll say tf dot squeeze x, and y is equal to tf dot squeeze y, and now we can plot this. So plt dot plot x comma y, plt dot grid, and then we have plt dot grid, and then finally we have plt dot show. So with this we should be able to see a nice plot. So that's the softmax plot that we have, softmax activation. As usual, what we'll do is also calculate the values of y in a different way. So in this case we'll use the tf, the relation that we have written up above, that's also from the docs, and we'll say tf dot math, or just tf dot math dot exp, tf dot reduce sum, and again here we have tf dot math dot exp. Again for y2 we'll reduce the dimensions. Y2 is equal to tf dot squeeze y2, and we can plot them, overlay plot plt dot x comma y2, and what we get in the output it's an exact overlay of the plot that we had seen earlier. So that's how the softmax activation function looks like. If you have any comments or suggestions, please do let me know in the comment section below. I hope to see you all in the next video. Please like, share, and subscribe. Thank you.